Welcome to the talk about Kotlin and the new and noteworthy, what is happening and what are the updates that are coming into the language. You are probably all Kotlin users, or you are just wannabe Kotlin users? Anyone is not using Kotlin yet and just looking into it? Some of you, it's okay, don't be shy. So Kotlin started as a alternative JVM programming language, and it was announced in 2011. So if you hear someone saying it's an Android programming language, no, it wasn't designed to be an Android programming language. It just happened by accident. We started the project as a just better Java. In 2011, that was the time when Java wasn't moving too fast. That was the post-acquisition, Sun's post-acquisition by Oracle, and the community wasn't sure what will happen to Java, and a lot of different languages appeared at that time. You probably remember Ceylon, Phantom, Gozu. There was like a dozen of them, and Kotlin was just announced even later than the others. And it was announced as a general-purpose, statically typed, object-oriented alternative JVM programming language with type inference. And type inference was like this novel thingy that made some people think that Kotlin is a dynamically typed language because you couldn't see the types specified and they were inferred. And, but that was wrong. Of course, it's statically typed and strongly typed. Normally, at the meetups, I would ask people to name their favorite language features. I will be, but I talk to people a lot, and mostly opinions are converging on the same things. And people name null safety as one of the prominent features that the language offers as part of the type system. Of course, coroutines for asynchronous programming, multi-platform capabilities. Syntax is probably the most emotional part of the language. When I ask people, why did you choose to program in Kotlin, they say, I like the syntax, but they don't name exactly why, what exactly they like about the language and what features of the language they like. They just like the syntax. In fact, standard library gets a lot of mentions as well. It's a very convenient tool. But I will be selfish at the moment. I will talk about my favorite features of the language instead. Not all of them, of course, but some very interesting ones that I like, and they might seem basic to you at first. So when we talked about comparing Java to Kotlin 10 years ago, we could show this slide and say, oh, see, like on the left, we can write the data class, and this results in something on the right-hand side. And today we have records in Java. And then this is what mostly people use as an argument. Oh, but Java has records now. What else Kotlin has to offer? Like, I have everything in Java. And I tell you, I had this argument in 2011 when Java 8 wasn't there yet. And all I needed just lambdas. I thought, like, I will get lambdas, and I don't need the other language anytime soon. And the irony is, I joined Kotlin team 10 years after. You see, like, we probably need a little more from the language to be happier. So I maintain this little page in the documentation. It doesn't fit on the slide, actually. And it becomes harder and harder to actually put the languages side by side, because some of like 10 years ago, you could just name features that are in the language and are not in the language. Now, with development of the compilers, the advancements in the compiler techniques, some of the features are overlapping. So you might have a feature in the language to do something, and the other language would not have this feature, but it would have another feature to do the same thing. Or they would have seemingly similar features like data classes in Kotlin and records in Java, but they are only seemingly the same. They solve different problems, they have different capabilities, they have different outcomes in the platform. So, if you talk about the features, Kotlin was always mentioned as a concise language, but conciseness is not the goal for the language itself. It's a nice extra capability, like nice bonus to make the language more productive, but the features in the language are not implemented with the goal to write less code. It's more about the trade-off, like how much code you write and how much you can read and understand what the code is actually doing. So there is a very intimate balance that the team needs to figure out when introducing those features. What we have that contributes to this conciseness, for instance, string templates, something that Java tried implementing and had to roll back this job and rework it. Hopefully it comes back in some other form, but it seems that it was overly complicated, right? In Kotlin, we didn't go that route. We didn't go implementing the template providers. It's just strings with interpolation and supporting expressions. So it was there from day one, and it was pretty simplistic and intuitive for people to adopt. And people like this. And this is the emotional part I was talking about. What else we have? Top-level functions. You don't think at first, as a Java developer, that top-level functions would change the way you write the programs. In fact, combined with the conciseness, and if you have top-level functions, suddenly you realize that you are structuring your programs in a completely different way, even though Kotlin at first day was positioned as just better Java. You see, suddenly the syntax capabilities allow you to write programs differently, especially with some other features in mind, like top-level extension functions, when you can add something into the existing types. This might spark some holy wars and arguments. Is this a good thing to do, or is this not a good thing to do? The real life is that we exist in JVM ecosystem. We cannot change the existing Java classes. We need to integrate somehow. For instance, Spring Framework provides the whole set of extensions for Kotlin developers to still use Spring Framework, but in an idiomatic way with those extensions, because functions have different capabilities, like, for instance, the default, or like, let's start with a single expression functions, for instance. This is something that comes to Java as well. And this is the part where we see, for instance, type inference kicking in as well. And this is the place where people started thinking that Kotlin is a dynamically typed language because we can infer types. But in fact, if you do it like in a wrong way, like if you use this function in a wrong way and you assign the value or the result of this function to something else that expects a different type, there will be a compiler error, so it's statically typed. What I was talking about, the different capabilities, is that, for instance, the default arguments is something that is, provided by the language, and you can use it idiomatically with Java libraries, with the existing Java libraries and the whole ecosystem as well. And having this particular feature in the language is like, well, if we added this feature into the language, into Java, for instance, we could remove the 80% of overloading needs. Let's say when you have multiple constructors overloaded or multiple functions with different variations, like combinations of parameters. This alone would contribute a lot, but alone, this feature doesn't play well in the language unless you have named parameters. Because if you have a list of parameters, all with the default values, and you need to override only one of them, you need to be able to say which one. Name it, right? So you see, there's like, it's not just like having one feature or just checklist of features that you have in the language. They need to compose well to actually provide a value. Trailing lambdas is a nice thing that you don't have to put a lambda or functional literal into the braces if that's the last parameter in the list or the only parameter in the list. So this feature is like contributing a little bit to conciseness where it's actually needed. Nullable types, null safety, remember. So we have null safety in the language, and the compiler warns us that we can get a null pointer exception if we don't check for a null. Alone, this feature on the compiler level, it's nice to have, but it's very inconvenient if you don't have additional tools to work with this feature, like safe call operator, for instance, or for instance, smart-casts, when we can check for a type, because here we check if the person is a string, person variable is a string, and or is not a string. Yeah. So basically, it results in smart-cast that the person could not have a nullable value, and the compiler will infer the nullability, verification there. So we don't have to use the save call and the others. Or my favorite concept in the language, building the DSLs, which actually comes very much from Groovy. It's not as powerful as it is in Groovy, because the language doesn't have dynamic dispatch. So in Groovy, you can implement the same thing, but it will be based on dynamic dispatch, which actually makes it almost impossible to check by the compiler. It all happens on the runtime. Here, you get a statically typed verification for the API calls, the assignments, everything. And we can make it even safer with the new upcoming features that are coming into the language. And we actually call them type-safe builders. Type-safe is in the name. So my name is Anton. I joined the Kotlin team, in 2020, right before COVID. And it was about time to release Kotlin 1.4. The release was scheduled for 14th of March of that year, but it was shifting out throughout half a year, and we actually released it in August that year. That was the clear indication of technical debt that happened with the language. It was announced in 2011, so that is 2020, and the language itself, the project itself, was already 9 years old at that time. And the team was aware that something is wrong. They couldn't move faster. They had some bugs in the compiler that they weren't able to fix because of the architectural decisions they made. Those decisions allowed them to move faster implementing the project, the language itself. But a lot of the language features appeared ad hoc. You see, as I was saying, you might add one feature, but you suddenly discover that it needs to play well with some other part of the language as well. So how could we solve that? And the team was thinking, well, we have to rewrite the compiler. We have to change the architecture. But why would you do that, rewriting completely, for something that actually works already? And there's so many man-hours invested, right? K1, the first version of the compiler, was a prototype. That was a prototype that was used for the announcement of the language. And normally you should throw it away. But the team was so keen on delivering the new stuff, and it seemed to be working, that, well, the prototype was shipped. And as I said, a lot of language features actually appeared unexpectedly. But the other things that involve that, for instance, compiling a whole program is totally different from when you need to work with the code inside the IDE. That's a totally different set of capabilities that you need from the compiler. And you want the IDE to be more responsive, to provide completions faster, syntax highlighting, and so on. So it wasn't really possible with the older architecture of the compiler, and this was partially the goal that the new compiler was solving. And compilation performance is something that you are never satisfied with. So we had this situation. We had to implement a new compiler, replace it in the ecosystem so that we don't break the platform, the libraries, the tools, the language itself, and so on. Because by that time, Kotlin was already a pretty popular language, popular enough to care about this. So the outcome was in 2024, last year, we released the stable version of the compiler. It took us almost 5 years to deliver, rewrite it to the new architecture, and we did not introduce any language features. So there was a lot of pre-work during the previous releases before this to kind of bring the consistency in all the language features that we already had, keeping in mind that Kotlin is not only the JVM programming language, but also a multi-platform programming language. But along the way, we fixed a few issues that we couldn't fix with the older compiler, but we didn't introduce the new language features, and we didn't change the existing ones. And the primary goal was still the correctness, so the old programs should compile the same way and faster. So the outcome for us internally was that the IntelliJ IDEA Ultimate code base, which is a huge repository with millions of lines of code, the compilation time for this dropped 40%, about 40%. So it very much depends on the code itself, on the shape of the code, what features you use in the project. It might be that it's only 5% for you, but it might be that it's 80% for you. So you gotta try. A little bit about the compiler itself. Very, very sketchy, right? There is a parser, which is a front end, and it generates some intermediate representation for the back end that generates the platform-specific code. Platform-specific, meaning in our case, Kotlin the JVM, but it can be a multi-platform as well for the web, for WebAssembly, for native platforms. And the IR is this intermediate form, like a data structure that the backend analyzes and generates the code. The front end is now implemented in two parts. There is a parser that parses the text, creates another intermediate representation that is then provided into the analyzer that can analyze different data flows. And for this, we are using the new data structure that is called a front-end intermediate representation. And I will explain quickly, very sketchy, what it is as well. So when you write Kotlin code, like normally, normal language constructs, at first stage, they are parsed and they are desugared into some common form. So for instance, the if statements are transformed into the when statements, when expressions. The normal for loop will be rewritten as an iterator loop, or some interesting language constructs like destructuring would be rewritten into some synthesized constructs. So you should think of a fear as a desugared form of the language, plus some meta-information about how the variables are used in the program, how they are passed as parameters, and so on. What checks are done on those variables. And as a result, we could implement, we were able to implement an analysis engine that checks the control flow and actually resulted in the improvement of some of the language features, especially the smart casts. Do you know about smart casts? Some of you, okay. So initially it was an interesting feature, but it was just a convenience. For instance, we have an animal, any animal, and then we check for the type, right? If the animal is a cat. That's just a convenience, right? You can do that with instance of check, and then you do a cast. So in here, it's a syntactic sugar that allows you not to do a cast, but on the next line to use this variable as if it's the type that we just checked for. And you will see that in the ID. It's usually highlighted. But if we extract it into a variable, into a conditional variable that we are using in this check, we're already introducing a data flow. You see, like the line before the actual check, there is the data flow. It's the variable is progressing through the application. So for this, we had to do some analysis work, and this control flow engine is now able to check that and infer the smart casts even in this situation. This is a very simplistic case, right? This is a very basic one. But let me show you some more complicated one. For instance, we have two smart casts on two different places in this function. So we introduce a logical expression for card withholder, where we check first if the card is actually of the specific type, or like any variable, the card variable is of a card type, after this check, if it's successful, then smartcast triggers in, and we can see, okay, we now can access the holder variable and call isNull_empty function. So calling isNull or empty on something that can be null, wouldn't it throw a null pointer exception? So how is it possible? Well, the thing is, in Kotlin, we can declare extension functions on nullable receivers as well. And if that could be null, the receiver itself, then we have a contract that implies that if it's not null, then it's a different type. It's not a nullable type anymore. It's not a nullable receiver. And this information is propagated out of this method into the compiler, so it could be used on the call side as well, and therefore, the second smartcast is happening. So you see, like we have this data flow floating through our program, and we can think of more complicated cases. If you go into the standard library and check some of the implementations, you will see smartcasts, kicking in various places 4 or 5 times in the function. Okay, so we can see that the compiler enables us to implement smarter features and more safer features and with more checks and so on. What's next for Kotlin? Well, there are 2 different directions that the team is taking with the language development. First of all, working with data. You probably have heard the term data-oriented programming used by Java folks very much in relation to pattern matching, records, and so on. So we have that goal as well. And stronger checks by the compiler. So as a library developer, I want my users of my library to be happy and to use my library in a safer manner and get assistance from the compiler. And there are many, many different situations where we can actually help the user and build up the contract between the library author and the users of the library, so that the library author could control in which manner the library and the APIs could be used, and then by using the compiler, the assistance from the compiler, the users of those libraries can also use the libraries in a safer manner. So whatever I'm talking right now is spread in time a little bit. After 2.0, we already had the release of 2.1. 2.2 is happening right now. So there isn't the final release yet, but it will be soon. And something that comes in a year as experimental. So just a tweet from yesterday, we released 2.2 RC2, and I think the team is going to publish the final release very soon. There are many different updates, but we are focused on the language right now. So it's not everything that I'm talking about in this presentation. It's not the full scope. It's just 10%. And we're going to talk about these features here, like the pattern matching adjustments, let's say, in the language, context parameters, some improvements in static checks, and some of the experimental features that are being in the design, but they are coming into the language in a year, and it's very interesting. So let's start with this example here. We have one expression that checks if the order of some specific type could be yearly subscription, monthly subscription. Well, there is a potentially logical error, and we can see some of the repetition. So remember, I told you that conciseness is not a goal in itself, but whenever the designers see that there is a repetition, they want to provide some tools for getting rid of this repetition as well. And it's possible. So first of all, we solve this problem with logical error, right? We need another branch. The other step would be to move out order into the subject parameter for the one expression, and therefore we can omit writing it on every line as well. Looks nice, but then we have this problem with logical condition, which is forbidden. This logical AND expression is forbidden in that place, and that was solved in 2.1 with introduction of the keep 371. Keep is like JEP, but for Kotlin. We introduced this syntax that we allow writing this guard condition as an if expression without else. It was experimental, and it seems that community accepted this. So usually we have this gradual rollout of the new language features, so that we release it as an experimental, then as beta. During that time, we collect all the feedback, all the corner cases that the community can come up with, and then decide whether or not we should go back to the whiteboard and redraw it, or we can release it as final. So in 2.2, this comes as final. And the compiler check the data flow as well, and would warn you if something is not reachable in this data flow. And 2.1, experimental, you can try it already now by enabling it, or just wait a few days and it will be stable, and you don't have to configure it, just use it. Yeah.
For me, I'm more Java.
Yeah. I get your point. There was a lot of discussions about this. Yes, there is always a trade-off. We know that. And we know that some people would say they don't really understand it. You cannot redesign the language. There is always a constraint, and there is how much you provide, the value that you provide, and how much damage you provide, let's say, right? There is always a trade-off. So this feature was in incubation for quite a while, and we decided to release it. I don't have my own stance on it, so good comment, I know, but let's move further. I don't have that much time. We can discuss it further after the talk, right? But it's not enough, right? If you compare to, let's say, pattern matching in Java, yes, you do have that matching, but that you also have binding into variables. And in Kotlin, we don't have binding, so it's pattern matching without binding. And instead, we have destructuring. And destructuring is a nice feature. It's based on data classes, and actually compiler generates the component functions, and they are position-based. And pattern matching is also position-based in Java. But there is a problem with position-based destructuring. For instance, I have this type here, with those values, and the outcome would be order ID 1, Anton, and some number after that. But what if I do refactoring, rename variables, change the signatures, change the order in some way, and the order of the definitions in the declaration would change and doesn't match exactly what we have in the type, and the destructuring is position-based. So we are introducing a logical error here, which will result in something else that is not expected, and the compiler did not help me to prevent that. This is not nice. You see, as the language evolves, we get new use cases, and then we need to somehow adjust for that as well. So what we anticipate here is that we could match by the name, and if the name does not match, then it's a compiler warning or an error. And in fact, we are working on the name-based destructuring, and but we have an existing syntax for destructuring already. We cannot just change the semantics already, otherwise the existing programs would not work. So even though it's seemingly a small problem, it's very hard to fix in a compatible way. So one of the proposals is to do this kind of syntax. So moving val keyword into the parentheses kind of signals to the compiler that the names of the variables should match exactly. Okay, but in this case, the nice outcome of this is that this feature does not depend on data classes anymore. It can just work with any classes, which is nice. So it comes as experimental in 2.4. it will incubate for a while, and then we collect the feedback. We see how the adoption goes, and then decide if we have to change it or come up with some other solution, and so on. So I covered in no order 2 features already. Let's talk about a very interesting beta feature that comes in 2.2, context parameters. This is the feature, a good example of the evolution, where we first released it as with the name context receivers. It received a lot of criticism. The design team came back to the whiteboard, redesigned the feature, and now it's a new proposal that incubated for a while, and now it's going to be added into the language, still as a beta. I will show you a couple of use cases, how this feature is applied in which situations. So remember I was talking about DSLs, my favorite concept. So as a library developer, for instance, I'm building a DSL to build instances of client objects. And there is a builder function that uses the functional literal with receiver as a parameter for this function, meaning that the users of my library could just use this, declare this block. Inside the block, they would assign the attributes to the client field and use it like as basically as a structure, right? They declaratively describe what kind of client they want to build. As you can see, there is this date object that doesn't have so much syntax as the other DSL. Maybe we can do better. And now I'm as a library author, I decide that, oh, I could use extension function that would introduce this nice capability of describing dates in my DSLs. The problem is that this function is declared on a global type, the integer, and now it's the namespace pollution that I introduced, a new function that will be available in all the scopes of the program where this library is used. Not nice. Can we do better here? Probably we need to restrict the scope somehow. Is there a tool for that? Well, yes, there is kinda, but it's not so like restricting. We can put this new function into the class or an object, make it private, and so on, but this is not enough in many cases. What we could do better is to declare a requirement for a specific context for the function, so that this function can only be visible to the compiler in a specific scope. And then the block that we declare for the DSL would have that scope. So, and as a library author, I would be responsible for providing this context. It can be, based on some condition, for instance. It doesn't have to be declared right in this line. It can be a factory method providing this different context objects, something else. And as an outcome, for the compiler, the function is only visible within that block. You see, like if we use this function outside, now it's a compiler error. The other, so yeah, it comes right now in 2.2 as a beta feature, but the other use case could be implementing a dependency injection, for instance, but for the functions. That's very interesting. So here I have an example of an interface, user service, and then you have a user service implementation, like the class itself. It's not implemented really, but assume it is. And then we have a declaration of this function with a context, so that the output message function should only be visible or should only be used within the scope of the user service object or instance, right? But we declare it as an interface requirement, so that the log function could be used, in this context. If we remove this, we don't see the users because it's a parameter. Like it is actually a parameter to the function, but it's a contextual parameter. And then on the call side of it, I'm providing this context into the scope, and I can call the output message function. If I don't have that, if I don't provide the context object, the implementation of it, as you can see, the compiler tells me, well, I cannot run it. It's a compiler error. So it's like a very minimal DI on the language level. Not like Spring that you scan the class path or anything. You have it under control. But it could be very useful as well. Yeah? Does it also have what? Back reference. I need to think about it to answer this, just not immediately. Let's talk about this. Yeah, the question is about some extra thing. The long one, I cannot even repeat it, sorry. Two other things I want to cover in the last 10 minutes. Reach errors, very interesting feature. You would not be able to try it right now, but I hope you will understand the concept from my explanation. So we have exceptions in Java, right? We have checked exceptions, we have runtime exceptions, and errors are actually exceptions as well. They are thrown. In Kotlin, we decided not to have checked exceptions for the reason that checked exceptions don't compose well with lambdas, right? So you like in those chains of expressions, they grow very verbose when you introduce checked exceptions there. And the philosophy of the team was that, exceptions should only be used for the cases where you cannot recover. If something bad happens and you can recover and you need to convey this information that something bad happened, this should not be an exception. It should be like a control flow feature. It should be a value feature or like type safety feature. So here's a toy example. And you know, we have this null safety, and we could use nulls as errors because we have the compiler checks on that. If something is null, then you know it's an error. But what if we use it like this? For instance, we fetch a user JSON, and then we parse this JSON. And if we get a null as a result, it means, what does it mean? We cannot distinguish, was it a network error or was it a parsing error that JSON was not correct. So what people do instead, they start mapping those different nulls into classes, into the types, and often using sealed hierarchies for that. So what happens is that you get this kind of code. Like you see, like we are fetching the user. If the outcome is null, then we are returning a network error. So mapping is happening right there. And we get kind of clear code, but with some nesting. Sometimes it's pretty nested. It's also a signal for the design team that, well, probably should do something else if it requires too much nesting. The code actually grows in verbosity, but the biggest problem is that it's very hard to maintain those sealed hierarchies in complex situations. Easy to make mistakes in that as well. The other approach would be using the result type from the standard library, which is pretty limited. It's extensible. It's like the extensibility is better with that, but then you introduce all kind of chains and functional operators to handle that. And you lose the non-exhaustiveness in when statements with that as well, because you introduce the else branch. Well, not a nice capability. So if we go back to the original example, this example is almost perfect. It's very simple, very linear. How can we introduce this feature into the language to keep this simplicity but still provide a better safety? So reach errors are kind of classes or objects, but annotated as errors. We first introduced them or announced them as union types for errors, But this sparks the impression that we are adding general purpose union types into the language, and that's not what it is. So we are not closing the door for the union types in Kotlin. We might introduce them, but we need to figure out this problem first. So that is why we are calling them reach errors. A good place for a meme with some king and the crown, but anyways, what it looks like by the syntax currently, by the proposed syntax, you would describe that an error, or the method can return a real type or some error, some definition of that error. Well, previously it was a nullable type, right? It was either a value or a null. Now it's either a value or some semantical information about the error. And then you can actually return multiple errors, but only one type, only one real type. So the code still will be the same, only the signature changes. But when you start, handling this compiler error, you actually will fall back into the when expression, and it provides you the exhaustiveness check. It provides you like better readability and type safety as well. That's the nice outcome of it. But what about exceptions? We still have exceptions in Java. Kotlin is part of Java ecosystem. We want to play nice with Java as well. And we don't have checked exceptions on purpose. So the standard library will have the standard library function right now to bridge the exceptions world and errors world. So if you need to call something that might throw an exception, you can use that standard library function, and it will be converted into a generic error type automatically for you. Okay, the other last feature I want to quickly cover in the last 3 minutes is the compiler capability that will be introduced in 2.2. Here's an example that will throw an error if you run it. Why? Well, it's you have to go through the code and understand why. The thing is, we didn't use the value in one of its branches, and that is why this error happened. Okay, nice we found it, but next time, let's hope that next time it will not happen. And seems that it's a syntactic problem, but actually even the best of us get that kind of mistakes. Here's another example of sorting the numbers and expecting the two minimal numbers to be printed, 2 and 4, but in fact we print 41 and 15, which are the two first numbers. Seemingly the collection was not sorted. Why? Because in the standard library, naming is hard, right? Naming is hard. Sort and sorted. One of them sorts the collection and returns a new collection, and the other one does it in place. Okay, would have been a better name. In-place sorting, right? Explicit, verbose, but, well, there is always a trade-off. So if we put those two examples side by side, we can see that in both cases, the result was not used, and that caused the error. So can we prevent this somehow? What is the naive reaction? Let's check all the unused return values. Well, the real life is that it's not very practical. You get too many false positives. Fortunately, not possible. It's just in some cases. It is practical in some cases, and unpractical in the others. So what we are introducing, not introducing, but let me skip this slide because there are existing solutions for static analysis that you can annotate some of the method calls or API calls that return values to be checked by a linter. Now we are introducing this kind of capability into the compiler as well. So the CheckReturnValue check, like inspection, will be built into the compiler, and first it will be opt-in. So if you really want to try it, you enable this capability for the compiler, and the standard library functions will be annotated using the must-use return value annotation. So this feature, this capability comes in 2.2, And later on, we plan to introduce it into as a public feature, and so that you could use it as part of the language as well. With this, I covered these number of features, right? The ones that contribute to the safety of the language. We actually have a lot more. If you want to check, we have this public roadmap of language features that we are working on in the design team. There's many of them, and I won't list them. And if you want the slides, you can go and check them on the slide deck, on a speaker deck. I'm here all the day. Anytime, find me. Let's talk about the questions you have, discuss them. Maybe I can take them back to the design team and discuss with them. Thank you very much for coming, and have a nice rest of the conference.